Hello and welcome. Let's move in and learn more about data. Data is information, especially facts or numbers, collected to be examined and considered and used to help decision making. Data can also be defined as information in any electronic form that can be stored and used by a computer. There are different data sources. These data sources can be classified into different categories based on their nature and origin. The following are the key data sources types commonly employed in the context of BI and data analysis. Foremost, we have operational data sources. These are systems that capture and store day-to-day transactional data generated by organizations' operational processes. For example, we have relational databases, enterprise resource planning systems, customer relationship management system. Operational data sources provide a granular transaction level details that are essential for tracking daily business activity. They are foundation of business intelligence by supplying data on customer interactions, sale transactions, and other operational metrics. Therefore, operational data sources are very crucial in the BI processes. Then we have external data sources. This is data obtained from external entities, not directly generated or controlled by the organization. This data enriches internal data sets and provide broader context for analysis. For example, we have market research reports, government databases, and social media data. Therefore, this is data generated from outside the organization. For example, note that external data sources offer valuable insight into market trends, competitor activity, and other external factors that can impact business performance. Integrating external data enhances the comprehensiveness of the BI processes. For example, companies may want to know about the share value and the share price of their competitors so that they can determine the best strategies to employ in the marketing of their own products. Then we have internal data sources. These are mainly internal data warehouses. These are repositories that consolidate data from various operational sources within an organization. Therefore, they provide a centralized and optimized environment for BI and reporting. Example of internal data sources are enterprise data warehouse and data marts. Then it's important to note that internal data warehouses streamline the data integration process by allowing analysts and BI professionals to access and unify consistent view of organization data. This enhances reporting accuracy and facilitate complex analysis by providing a single source of data. Let's move on to cloud-based data sources, sources in which data is stored on the cloud platform, and they offer scalable and flexible storage solutions. This facilitates accessibility and collaboration with other team members of the business intelligence team. Examples of cloud-based data sources are cloud-based databases such as Amazon Redshift and Google BigQuery. We also have cloud storage services such as Amazon S3 and Google Cloud Storage. Then it is important to note that cloud-based data sources provide the advantages of scalability, cost effectiveness, and accessibility. This enables organizations to handle large volumes of data effectively and collaborate across geographical locations. Next, we look at streaming data sources. These are data sources that continuously deliver data, allowing for immediate and real-time analysis and decision making. Streaming data sources support real-time analytics, enabling organizations to react promptly to changing conditions. This is particularly crucial in dynamic environments where timely decisions are paramount. Let's move to big data sources. These are sources that involve large volumes, varieties, and velocities of data, often beyond the capacity of traditional databases to handle effectively. It's important to note that big data sources cater to the challenges posed by massive data sets, allowing organizations to process and analyze vast amounts of information effectively. This is essential for uncovering insight from diverse and complex data structure. Example of big data is data generated, let's say, from Twitter feeds, that is from minute-to-minute tweets and minute-to-minute Facebook feeds. And then this data is analyzed and evaluated to determine what it means and identify trends and patterns in the data. Big data is commonly important for social media platforms, that is, social media companies like Facebook, Twitter, and let's say Instagram. That's it for data sources. And notice that these data sources are all important for organizations and for the BI processes. Next, let us look at different types of data files that are used in business intelligence. In business intelligence and data analysis, various file types are employed to store and manage data. These file types serve different purposes and are chosen based on factors such as data structure, size, analytical requirements. Here are some common data file types used in BI. We have the CSV, that is comma separated values. CSV is a plain or flat text file format where each line represents a row of data and fields within the row are separated by commas. And they are used for their simplicity and compatibility with various tools. And they are easily readable and can be opened in spreadsheet software. CSV files are suitable for tabular data representation and are commonly employed for data exchange between different systems. Then we have Excel files. These are Excel files that store data that can be opened using spreadsheet. And Excel files are mostly XLSX, but we also have different versions of the Excel files. Excel files, especially those of the XLSX format, are spreadsheet files that can contain multiple sheets, each with rows and columns of data. Excel files are popular for their user-friendliness and are often used for small and medium-sized data sets. They provide basic data manipulation and visualization capabilities, making them suitable for initial data exploration and analysis. However, note that Excel files are not suitable for large data sets because they are not scalable and they take a long time to load if the data is too big. A good example is when working with a 5 GB data set, it's impossible to work with Excel files because they restrict the processing powers of the computer. Then next we have the JSON file, that is JavaScript object notations. JSON is a lightweight data exchange format that uses a human readable text format to represent data objects consisting of attribute value pairs. JSON is commonly used for semi-structured and nested data. It is prevalent in web-based applications and APIs. JSON's flexibility makes it suitable for scenarios where data structures can vary, and it is often used in conjunction with NoSQL databases. This is another format mainly used for web-based applications, and it's mainly important in transferring data set from one format to the other. Then we have XML. This is also like the JSON file. XML is a markup language that defines rules for encoding documents in a format that is both human readable and machine readable. XML is used for representing structured data with hierarchies. The part format is a columnar data storage format optimized for use with big data processes and frameworks such as Apache Spark and Apache Hive. Its columnar structure enhances compression and enables more efficient data reading for analytical processes. Then we have database files. These are files from different databases. And note that various database systems use specific file formats to store structured data. For example, SQLite uses a single compact file, while PostgreSQL may use a set of files in a directory. Database files store data in a structured and a relational manner, facilitating efficient querying and retrieval of specific information. They are commonly used in BI and data analysis for managing large data sets with complex relationships. In this case, we look at SQL data files and learn how we can use MySQL Server in business intelligence. Note that the data file used is highly reliant on the data sources and the structure of the data sets. See you in the next lesson.